Alright guys, we're back with our pneumatic joint project. This is part 4. What we're going to do here is we're going to go through and we're just going to add fasteners to this. There's not a lot. Essentially we're just going to put screws in either side of the standoff for the main pivot. We're going to put a screw and some washers to act as spacers on this end of the air cylinder, and we're going to do the same thing. We're going to put a screw and washers for spacers on this end. For the washers, I'll show you guys how to use the pattern feature in an assembly, which is something we haven't really messed with in the CAD class just yet. Stuff we're not going to do, I'm not going to put rivets in. We never do that in CAD for FRC. It would take too long and doesn't really serve any purpose. The rivet heads don't stick out very much, and if there's any time where we're worried about a rivet hitting or something, we kind of just take some measurements to see if we have room. And we're also not going to put fittings in the air cylinders. I don't think we've ever actually had an occasion to do that in our CAD models. You could, if you're worried about clearance, you could put a fitting in there. Typically we kind of just eyeball it, and like I can tell like by looking at this, there's enough room to put a fitting here. It'd be a little close because the fitting does extend beyond the edge of the hole a little bit, but I don't see any problem there. Okay, so what we're gonna do is, well, I'll start with these because these are easy. So it's an 1/8 inch thick bracket going into a threaded hole. Threaded hole is about 1/2 inch deep. Typically, when we're putting screws in the end of standoffs, we pretty much always use 1/2 inch long screws. That's what we keep the most in stock, and the thread depth, especially when you take out this 1/8 of an inch for this plate, there's plenty of thread depth for them. So that's what we typically use. I think we're going to use a button head just because it'll look nice here. Depending on what the application is, you could use a button head or a normal socket head. A socket head, you'd be able to get a socket head tighter without risking the screw stripping out. But you might need clearance for a button head or something. So we're going to use a button head. So this will be a button head cap screw. Just going to download the CAD models from McMaster Carr like we usually do. So it's going to be these alloy steel ones with the black oxide finish. They're the cheapest. We don't really need a lot of corrosion resistance. I talked a lot more in detail about different fasteners and stuff in the gearbox project. So if you haven't watched those videos, or if you weren't in the class, be sure to check those out because we go into a little bit more detail about some of our fastener selections. So the thread designation was a 1032 for the standoff, so we're going to pick 1032 for the thread size. The length, 1/2 inch as measured from under the head to the end of the screw. So we're going to pick this black oxide steel one. Click on the part number, go to product detail, save it, give us a step file. So we're going to cut that out of there. I think I have it open. Yep. Alright, just going to paste this in here. I'm actually going to, this is something I do a lot, an archive folder, so I can throw old step files in there so that they don't get in my way, because there's no preview for the step file in Inventor, so you can't see what it is you're opening, and looking at file names can sometimes take a long time. So alright, so we're going to open this up. That's the one we got there. Wait for it to load, click OK. Oops. Come on. Delete the sketch. We're going to pick steel alloy. Then I usually go for this glossy black color because it shows up nicely. Alright, so we got to pick a cylindrical surface, get an axis in there. We'll just go with the rim here. I think the domed head would work as well, but the rim's definitely a cylinder. So give that a save. We're not going to put these in just yet. I'm going to go ahead and get the rest of our CAD models going here. So this is measure this here, activate the measure tool with the M key usually. So it's a 1/4 inch, and going to measure from the outside to the outside. So we need 1 1/4, and then we're going to need a nut on this side. Now what we're going to do is we're going to use a Nylock nut. And what a Nylock nut allows us to do is it allows us to we don't have to tighten it down all the way, right? And then it won't come off. So if we just used a normal nut and we tightened it down, we would, in order to get it tight, we would have to like smash these two plates together, which would bend them, and it would damage the mechanism. So we need a nut that we can not put on all the way, and then well, yeah, we need a nut that we can put on all the way, and it won't come off, which a Nylock nut allows us to do. Now, I think what I'm going to do is I'm going to use, well, I think I'm going to do two different methods. So I'm going to do a screw and a Nylock nut in one place, and then on the other place I'm going to use a shoulder screw. And you can do either. With a nice fractional number like this, I believe you can get shoulder screws for 1 1/4 inch long pretty easily. So I'll show you kind of both methods. Now typically you would use either one or the other, but for this example I'm going to do one of each so that we can kind of see both. So we need a, well, let's go look how tall the nut is first. So let's look at Nylock nuts. I don't know. 1/4 20. They're going to be zinc plated. I can never remember what grade it is. So grade 5. I believe this is what we usually go for. I believe it's usually grade 5 that we use. It doesn't really matter for this because the outside dimensions. Okay, so the nut is, this is what I wanted to look at. So the nut is 5/16 of an inch long. And then, so we've got 1 1/4 inch plus 5/16. So it's going to be more than 1.5 inches. It's going to be 1 inch and, well, 9/16. So, and then the end of the screw is tapered a little bit, which means you've got to make sure that you get like a full thread in the nylon. You don't want just the tip of the screw coming through because the tip of the screw doesn't have full threads on it. So you want to make sure you've got a full threads going, a section of the screw with full threads going through the Nylock portion. So we could go, we're probably going to have to go with 1 3/4. It's going to stick out quite a bit on the back side of the nut, but that's a nice fractional size that like we would have. You could go, I don't even know if you can get 1 5/8. But 1 5/8 is probably cutting it a little close. You probably wouldn't have a full thread here. So we're going to download this CAD model. So this is a 1/4 20 because as I mentioned, this is a 1/4 inch. You could use 1/4 28 if you wanted. It's just pretty common with that did not save. There we go. It's pretty common with FRC teams to use 1/4 20 stuff, so that's why I'm doing that. We talked about that a little bit in the gearbox project once again. All right, so we're going to do a socket head cap screw. We're not going to use a button head here. Socket head cap screws, alloy steel socket head cap screws. Okay, so thread size is going to be 1/4 20, length. So you can get 1 5/8. Well, let's actually just look down the list here. So yeah, so I mean the 1 5/8 is like double the price of 1 3/4. Actually, oh, no, that's fully threaded. Well, they're about the same price. Okay, it doesn't matter. You know, normally in the season you'd want to think about price a little bit, but you know, fasteners is typically not a big deal. But I'm not super confident, you know, in making sure that we get that thread, so I just go a little long. Plus, 1 3/4 is a common size that we would have probably in the shop and not need to order special for this project. So let's give that a save. All right, so then let's So let's look at shoulder bolts. So we know that this one's the same. It's 1 1/4 inch. So let's do shoulder screws, alloy steel. All right, so excuse me. So we know the shoulder diameter, the diameter of the shoulder is going to be 1/4 inch because that's what the part's going to be as a pin. So basically, the shoulder length is going to be our 1 1/4. That's a fairly common size. And that they always come in, shoulder screws are always in coarse threads, so we're going to have to do 1024. So we're going to have to use a 1024, probably Nylock nut for this, which means we're going to have to download another CAD model. All right, so let's download this. I'm going to rename this file because I know for a fact that the 1024 one's going to be named like the same thing. So I want to just make sure that we differentiate between the two. Don't need that anymore. I'm going to archive that. You could probably just delete those usually, but I don't want to mess with it right now. All right, so now we're going to get a 1024 Nylock nut. So grade 5. Oops. I don't know. Oh, so you only get low strength. I don't normally order my nuts from McMaster-Carr because you can get them cheaper in bulk quantities from other suppliers. So typically for Nylock nuts, I'm not ordering them from here. I believe they are grade 5 from where I order them. I don't pay a lot of attention to it because in FRC it doesn't really matter. Okay, so this is going to be a 1024. Like I said, I'm just renaming these files so that I can tell when I import them which is which. Cut that out and paste it in here. All right, so we need washers to act as spacers. So flat washers, general purpose washers. Oops, keep going past it. 1/4 inch. 18/8 stainless steel is going to be the most common one. Just going to save that. All right. Okay, so to review, we've got 5 fasteners here. So we've got, I'm going to go back to the CAD model here. So we've got a 1/4 20 socket head screw for in here. All right. That screw is going to have a Nylock nut that's not going to be tightened down all the way. It's just going to be tightened so it just barely touches this plate. Okay. Then we've got washers that are going to act as spacers in here. Then on this end, we're going to have a shoulder screw. The shoulder is going to be flush at this end, and then we're going to tighten the nut down, and we can actually tighten the nut down on the shoulder. And the shoulder screw itself will be fairly loose, but it'll be held firmly in place, and that'll act as a better pin. And then once again, we're going to use washers as spacers. So let's start importing. Let's import all our files, and then we'll go into the assembly and put everything together. All right, so I'm just going to start at the beginning of the list, start going through and setting materials. So this is going to be steel, and then I'm going to set the material to zinc because these are zinc plated. I'm also going to change, this is what I typically do, I go up to the solid bodies. For those of you who remember with the air cylinder, we talked about solid bodies. Same thing here. You can color solid bodies separately in Inventor. So typically I go and find this nylon thing and I just color it a nylon color. Nylon 6. That's fine. Alright, so then we need a work axis. I'm going to pick the work axis tool. I'm going to pick some round surface, in this case this kind of radius here. Put that in there and save that. Alright, so now I'm going to open again. So we did this one. We're going to do this one next, which is going to be the other nut. The 1032 one. So that was the 1024. This is the 1032. Yeah. Alright, so delete the sketch. set the material to steel, set the appearance to zinc, which I zoomed, go to the solid bodies, pick the nylon one, go up and set that to a nylon color, then pick the work axis tool, pick a round surface. Alright, give it a save. I'm just using Control S to save. And then I'm going to use Control O to open. Like I said before, I always use keyboard shortcuts if I can. Alright, this is our 1024 screw here, or not our 1024, this is our 1/4-20 screw here, I believe. Click OK. Alright, delete that. Okay, so material for this is going to be alloy steel. The appearance is going to be black because it's going to be black oxide, like pretty much all the fasteners we use. Alright, so that's, and then I just place the work axis down. I'm going pretty quick here because we've already done this once on the gearbox, so I figured you guys know how to do this. If I go too fast, you guys can always rewind the video. This is kind of an optional part. In a lot of cases, we would not put these fasteners in an actual CAD model in the build season just to save time, unless there was some question about clearances and if some fastener was going to hit. So we usually just budget weight for fasteners. We budget like 10 pounds or something, and that gets us by usually. So gonna keep going down the list. We got 2 more, including this one. Alright, so this is our shoulder screw. So this is going to be alloy steel, and there's no finish on these. They're precise enough that they can't really put a finish on them. So they're polished, and they usually douse them in oil, so they come in all oily, but that keeps them from corroding in a lot of cases. So we're going to put a work axis here. We talked about shoulder screws briefly in one of the COTS segments in the actual in-person class. So basically how they work is there's a really precise length from here, which is called the shoulder, to the under the head, and basically you tighten a nut down, and you can tighten it against this shoulder, and then basically that it means it doesn't squeeze anything in between, and then you can use this barrel, which is a really precise precision ground surface, as a pin. These are also called stripper bolts, and the reason they're called that is a punching or a stamping die typically has a part that's called a stripper, and basically what the stripper does is it pushes the material off of the punch. So basically, if you're punching a hole in a steel sheet, for instance, your punch is going to go through the sheet, right? You're gonna have a hole. You're gonna punch. You're going to have a hole, and you're going to have a punch that fits in that hole. You're going to put the sheet between the hole, which would be the die, actually, and then you punch through, right? So the punch goes through the material. Well, it tends to get stuck, right? So you've got to have kind of like a part that pushes the sheet back off the punch as the punch retracts out of the sheet. And that part is called the stripper. And basically what the stripper bolts are used for is they're used as like a linear guide. So basically the stripper would slide up and down on the barrel, and that's why the barrel is a precision ground surface. So it stays, it moves nice and smooth. So that's what these are typically used for, but they're good for pins and other things as well. So that's that, and we just have our button head screw now, which should be this one. Oh no, this is the washer. We already did the button head screw. Alright, I'm going to delete this. Alright, so delete the sketch. Set this to stainless steel, which is what it is. Axis, just pick the inside of the washer. Save it. Alright, I'm going to close all these because we don't need them open for assembling. Don't need that one either. Alright, so let's start with the button head screws here. So I'm going to do my right mouse drag up trick to do the place component command. You can also click it on the ribbon if you want. Alright, so pick our button head screw. I'm going to rotate once by the y-axis, place it down on this side, and then I'm going to rotate twice by the y-axis again, place it down, press escape to get out of the tool. Alright, so I'm going to activate the constraint tool. I'm going to constrain this using the work axis. Actually, no, I'm not. I was talking about in the in-person class last time, today actually, and I was saying I need to get more in the habit of using the insert constraint because it really is a lot easier. So I'm actually going to use that. So to use the insert constraint, so normally, just to review, normally I would constrain this work axis to this hole, right, to this work axis maybe, and then I would constrain the head, the underside of the head, which is the flat surface, to this flat surface, right? Two constraints. Well, basically what the insert tool does is it does those two constraints in one constraint, so it saves you mouse clicks. And really, it's meant for fasteners. That's what the insert constraint is for. So if we go up here to the place constraint dialog, it's the fourth one over, so it's this guy right here, insert. There's two different directions, but this first one is going to be the one you use most of the time. So basically what you're going to do is you're going to pick a circle, right? So and you want to make sure you pick a circle that's on this flat surface of the underside of the head. So I'm going to pick this outer rim here, and you can see this arrow is facing towards the end of the fastener, which is what we want. Then I'm going to pick another circle, which is going to be like the rim of the hole. And basically, these two circles need to be on the planes that are going to mate, right? So you can see if I'm going to undo that. So I'm going to go back and undo this again, but I'm going to pick a different circle. So if I go to the insert tool and I pick, oops, I hit the escape button by accident. Insert. All right, so if I pick this circle, same circle I picked was before, but if I go and pick the back of the hole, you'll notice it puts the fastener on the other side, which is not what you want. So you want to make sure you pick the right surfaces. Come on. Alright, so that's good. I'm going to press enter. Alright, so I want to explain something. I haven't explained it in the in-person class, but I want to make sure we're clear. So I was able to constrain that and then press enter without clicking the apply key. However, I'm going to do something different. So I'm going to constrain this, constrain that, and now I'm going to move the view, right? I just panned, you could orbit, you could do anything you want, but I moved the view. Now if I press enter, it doesn't work. And the reason for that is because when I move the view, this dialog becomes grayed out. So in order to be able to press enter, this dialog has to be selected. So if I click on it, it gets back selected. Now I can press enter. So if you're going fast with your constraints and you happen to move the view before you press enter, which is easy to do, if you move the view before you press enter, it's not going to work. You're going to have to click on the window and press enter, or just click on the apply key, button. Okay, so those are those two. Let's place more components. Let's keep on going here, and I just lost my previews. Great. All right, it's that one. I had some weird Windows glitch where Inventor will stop showing these previews. I don't know what causes it, but you have to restart your computer to do it, if I remember correctly. All right, so that's the one I want. All right, I'm going to rotate 3 times by the y-axis because I want the head on this side. Doesn't really matter, but that's the way I'm going to do it. So place that down. I'm going to use the insert tool again. Now these you got to be a little careful because they have a chamfer here. You want to make sure you don't grab this outer part of the chamfer. You want to grab this one because, like I said, you need to pick a circle that's on the flat face of the fastener. I'm going to pick that. Pick the rim of this hole. That should be good. Okay, so yeah, so you see how much is sticking out here. I mean, the nut's going to take up a decent amount of that, but that's more than we really need. But it'll be okay. All right, so let's place our nut. This is 1024. We want that one. 1032. Oh no, we don't want 1030. Oh, did I download the wrong nut? Oh, I downloaded the wrong nut. I didn't need a nut for this. I'm an idiot. Okay, I got one more to download. I screwed up. Okay, so we're going to go back to this. We're going to pick, I need a 1/4-20 Nylock nut, not a 1032 Nylock nut. Grade 5, product detail, save. Cut. Oh, I just lost it. Gosh darn it. It's this one. You can't actually type 1/4 because you can't use a slash, so I usually just do 0.2520, which is, it's a horrible, horrible thing, but it's the way I do it. All right, so let's open that. Let's go to this one. Sorry about that. I was talking and downloading files at the same time, and I went and downloaded the 1032 out of habit. Okay, delete that sketch, set the material to steel, set the appearance to zinc, set the nylon portion to nylon, place our work axis, give it a save, close the file, go back here, pick the Inventor model, and I forgot to turn off my Google Drive syncing. Let me do that before it causes me problems. Pause. Alright. Bad things happen if you're syncing and working at the same time in Google Drive, so I want to make sure. Alright, so rotate it once by the Z-axis to turn the nut the right direction. I'm going to use, I think I can use the insert on this round surface. Some fasteners you're not going to have a round surface, you're going to have to constrain it normally, but alright, insert, I'm going to grab that. It can be an arc, doesn't have to be a circle. And then that circle there. Yeah. Alright, so yeah, you see how much is sticking out the end, but I mean that's kind of unavoidable. Alright, so let's well, need the washer. There we go. Alright, so once by the Z-axis. Alright, so same thing. Constrain, insert, pick a circle, pick that circle, and apply. And I actually should have placed two of these. Come on. There we go. Once by the Z-axis. Constrain, insert, pick a circle, pick that circle. Alright, so now let's get the measure tool with the M key. Let's measure the thickness of this washer. So 0.057. So if I measure the distance between here and here, I just need to figure out how many to stack up. 0.057. Alright, so it's 193. I'm not doing this in my head. So I can get 3 more in there, and I can't obviously have 0.38 of a washer. So alright, so that's going to be 4 stacked up. So here's what I'm going to do. I'm going to click on this. So, well, actually, I'm not going to click on it. Alright, so I have nothing selected. So I'm going to go up under here on the Assemble tab. I'm going to go up where it says Pattern. Click on Pattern. Now, I want a rectangular pattern. In this case, I'm just going to pattern in one direction, but I want a rectangular pattern. So I'm going to pick Rectangular. Then you got to pick the direction that you want to pattern one of the rows in, or the column in this case. So pick the arrow, which is the column direction. We'll just pick, we just got to pick an axis. So that works as an axis. Now the arrow is going the wrong direction, so we're going to click this little like curvy arrow thing, flip it the other direction. Now we know the thickness is 0.057, so that's going to be the center to center distance. So we're going to go 0.057, and then oh, right, we got to pick components. Well, we're going to do 4 total. So 4 includes the original. You want to make sure it's including the original. So we need 3 more, so it's going to be 4 total. So we're going to pick the component by clicking on this arrow and click on the washer, and it stacks a whole bunch of them up. Now, like I said, normally we wouldn't do this, but I just wanted to take this opportunity to show you guys how to use the pattern feature, and then it shows up here in the browser as a component pattern. And all the elements are here. So that's an easy way to place a whole bunch of things. You got to be a little careful when you're using this. You can overuse it, and then it just becomes impossible to work with. I don't use component pattern very often, but in some cases like this, it's pretty useful. So we're going to do the same thing with the other one. We could have done this in such a way that we could have done both of these at once, but that's not the way it ended up working out with the way I constrained it. So we're gonna. You can also select the washer, then click pattern, and then you don't have to like go up and select the component because the component's already selected. All right, rectangular. We're gonna pick our column. We didn't have to click on the arrow because when you already have the component selected, it knows you want to pick the direction first. All right, so that direction is right. You can see it's a pattern of 2 with a 2-inch center to center distance, so it's floating out here. So we want this to be 0.057. Which is the thickness of the washer, and then once again we want 4 because it's going to be the same on the other side, and click OK. Alright, so there's a little gap, but that's not a problem. That's plenty tight enough to keep the cylinder centered. Alright, so let's drop in our shoulder screw down here. So I'm going to place component. I know it's this one. I'm I'm going to rotate once by the y-axis. I'm going to keep the head on the same side as the head of this screw. Once again, doesn't really matter, but that's what I'm going to do. All right, place that down right there. Press escape to get out of the placement tool. I'm actually going to go ahead and drop my nut in just so I don't have to do this again. So this can be the 1024 nut. I'm going to rotate once by the z-axis. Yeah, it's facing the right direction. Okay, so I'm going to just place that down there. Press escape to get out of that. All right, so I'm going to constrain. I'm going to go to insert. I'm going to pick the bottom of the head, just like we would for any screw, edge of the hole, enter, and then the nut, I'll pick like this arc here, and you see how the end of the screw is flush with this surface, so I can just pick the edge of the hole. I could have picked the edge of the bolts as well. And then we've got this like nice round surface, because the problem with doing it this way, right, is you could have threads. Right, you see how the threads are inside of the clevis, which means you don't have like a nice smooth surface for this to ride on, so it can eat up your clevis and stuff. So this is it's typically okay, especially since the clevis is steel, especially for an FRC application. This really doesn't cause any problems. The screw threads in the aluminum do cause problems. So if this was a high load mechanism, this would not work at all. So this only works for really low load stuff, because the threads can eat at the aluminum after you cycle this a bunch of times. We've done it on Stellar, but we've also had to deal with it damaging the aluminum bracket. So in a lot of cases, the slop that it generated was not an issue, so we just kind of ignored it, and it was able to make it through the whole season and all of our off-season events. I mean, something like this, if it makes it through 7 events or something like that, it's good enough. I mean, it's not in good shape by the end of the season, but it makes it through. But the shoulder bolt is definitely the better way to go. The problem with the shoulder bolt is you're constrained to the lengths of the shoulder you can get. In this case, it happens to work out really nicely. In a lot of cases, you might either have to change your design so you have a nice fractional distance between the two like plates in this instance. Or you'll have to, or you like when you tighten the nut down, there'll be some extra left over if you're doing something with a weird dimension. Hard to say. But in this case, it doesn't really matter. All right, so we're gonna place some washers in here, and we're gonna do this a little bit differently just to show you. So I'm gonna rotate once by the z-axis. I'm gonna place 2 down. Press escape. All right, constrain, insert. Pick the edge of the washer and the edge of the hole, apply, edge of the washer. Now I'm going to constrain this against this side of the air cylinder so that we can do both stacks of washers in one pattern. So pick the edge of the hole, click apply. All right, I press escape. Then I'm going to go back to the pattern tool. Now I have not selected my components yet, so I'm going to go ahead and, by default, this component selection tool is activated. So I'm going to pick that, and then I'm going to pick that. All right, and you just click to select multiple items. So both of those are selected now. So I'm going to go to rectangular. I'm going to pick column. I'm going to pick this work axis, and then I want it to go the other direction. So I'm going to click this flip direction button. Now we know the center to center distance is still the thickness of the washer, so 0.05, and we want I think it's, I didn't measure it, but we can just eyeball it. Yeah, 5 is good. Okay, yeah, that's another thing too. You can just eyeball this if you want, but if we go 6, it'll clip. You can see it's clipping into the part, which is not what we want. So that's 5. So you'll notice, because we're patterning these two as like a set, right? So it's patterning multiple parts at once. You know, we had to pattern them both the same direction. So we had to constrain this against this, and then the gap is on the outside as opposed to on the inside here, which in this particular case it doesn't matter because these washers are going to rattle around loose on this rod anyways. So this is just saves you from having to do 2 patterns. So on this end here, this is one way to do it. On this end, this is the other way to do it. CAD students, if you guys want to pick one or the other, I am perfectly okay with that. So if you don't want to do it differently on either end, you want to do it the same way, you can do both of them like this, or you can do both of them like this. It's up to you. You can take a little bit of a, you know, liberty with your design there, I guess. But this is as far as we're going to go with this project. This is the final product, and not too complicated, but it's a good thing to be able to know how to do, because you're going to build structures like this multiple times on every robot. So that's that. Thank you for watching, and we'll see you on the next one.